Have you ever been deep inside a building, maybe in a basement or a huge shopping mall, and you look at your phone and wonder how on earth does Google Maps know exactly where I am? It seriously feels like magic. Well, today we're going to pull back the curtain and show you exactly how the trick is done.
I mean, think about it. It's one thing when you're outside in an open field, right? But how does it pinpoint you inside a complex building, sometimes down to just a few feet? We all kind of know that GPS signals have a really hard time getting through a roof. So what's really going on?
And right there, that's the first big myth to bust. If you think it's all about satellites beaming signals down to your phone, you're only seeing one small piece of a way more clever puzzle.
The truth is, your phone is using a team of 4 different technologies, all working together in this incredible symphony of data. You've got GPS satellites, sure, but it's also talking to cell towers, scanning for nearby Wi-Fi networks, and even using the tiny little sensors packed right inside your phone.
Okay, so let's start with the one we all know, or at least the one we think we know, the Global Positioning System, GPS. This is the foundation, the big picture view from the sky that gets this whole thing started. So at its core, GPS is this whole constellation of satellites just orbiting the Earth, constantly beaming down these little timing signals. Your phone's job is to listen to those signals and use them to figure out its latitude and longitude. But how does it actually do that math?
Well, it uses a really cool process called trilateration. So if your phone picks up a signal from one satellite, it just knows you're somewhere on a gigantic circle on the Earth's surface. A second satellite signal narrows that down to just 2 possible points where those circles intersect. And then, bam, a third signal lets your phone pinpoint your exact 2D location. A fourth satellite adds altitude into the mix and helps correct for any tiny timing errors, giving you that perfect, accurate dot on the map.
But here's the catch. As powerful as GPS is, it's not invincible. Those satellite signals are actually pretty weak by the time they reach us, and they get blocked really easily by, stuff. Concrete buildings, subway tunnels, even the urban canyons you get between skyscrapers. This is where GPS starts to fail, and it's exactly where the other technologies have to step up and take over. So let's move on to the next layer. We're coming down from the sky, and we're going to look at the ground-level network of infrastructure that is literally all around us. Cell towers, and you guessed it, Wi-Fi. So first up, cell towers. Even if you have absolutely zero GPS signal, your phone is almost always connected to a cell tower just to get service, and your phone company knows which tower that is. So just by knowing the tower's location, it can get a pretty rough idea of where you are. And if it can see signals from a few different towers, it can use a similar kind of triangulation to get an even better guess. But rough is definitely the key word here. In a city where the towers are packed in pretty tight, the accuracy might be around 100 meters. But out in the countryside, where they can be miles apart, that accuracy can drop to a kilometer or even more. So it's a fantastic backup for sure, but it's not going to tell you which store you're in at the mall.
So if cell towers aren't quite precise enough, what is? Okay, this is the part of the story that most people have no idea about, and it is the real secret weapon for that amazing indoor accuracy.
The secret is something called a MAC address, or a BSID. The easiest way to think about it is like a totally unique serial number, a digital fingerprint for every single Wi-Fi router on the planet. Your router at home has one, the one at the coffee shop has one. Every single router in that shopping mall has its own unique fingerprint.
And here is where the magic really happens. Your phone is constantly scanning for any and all Wi-Fi networks in range, and this is the key part. Even if you're not connected to them, it sees their unique MAC addresses, and then it checks them against Google's enormous crowdsourced database that basically maps these router fingerprints to their physical real-world locations. And because Wi-Fi has such a short range, if your phone can see a certain network, it knows you must be very close to it.
So let's do a quick recap with this little smackdown. GPS, that's the king for outdoors, clear skies, getting you down to about 5 to 10 meters. Cell towers, they're the broad backup plan for when all else fails. And Wi-Fi, that's the star player for indoors and in dense cities, often getting you within 10 to 30 meters of your real spot.
But hang on, there's one last piece to this puzzle. We figured out where you are, but how does the map know which direction you're facing, or that you're actually moving? For that, we have to look inside the device itself, at your phone's inner compass for that final bit of polish.
Your phone is just packed with these incredible little sensors. You've got the compass, which of course figures out which way you're pointing. The accelerometer detects when you start moving and how fast you're going. The gyroscope senses every little turn you make. And get this, the barometer can even detect tiny changes in air pressure to figure out if you've gone up or down a floor in a building.
When you put them all together, these sensors are what create that seamless, fluid experience we're all used to. They are the reason you see a little blue arrow pointing the way you're walking, not just a static dot that jumps around. They make the map feel alive, like it's moving and turning in real time right along with you.
Okay, so we've looked at all the individual parts: GPS, cell towers, Wi-Fi, and sensors. Now let's put it all together and see how this creates the full picture and what it means for you.
Just think of it like a smart location formula. Your phone is constantly evaluating the situation. If it has a clear view of the sky, it's going to lean heavily on GPS. But the second you walk indoors, it instantly pivots, prioritizing all those Wi-Fi signals. Cell towers are always there in the background, just in case, acting as a safety net. And all the while, those internal sensors are adding that continuous layer of smooth, dynamic movement.
Let's use that shopping mall example again. Picture it. You walk inside and your GPS signal is basically gone. But your phone immediately sees the Wi-Fi networks for the food court, the shoe store, the department store, all of them. By checking those signals and their strength against its database, Google Maps can still place you with flawless precision, guiding you right to that pretzel stand.
And now that you know the science, you can actually make it work even better for you. Go into your settings and make sure high accuracy mode is turned on. That tells your phone to use everything it's got. You should also enable Wi-Fi scanning even when your main Wi-Fi is off. And hey, if your little direction arrow seems off, do that thing where you move your phone in a figure-8 pattern. It sounds silly, but it really works to calibrate the compass.
Now, of course, hearing about all this data flying around might spark a pretty important question. If my phone is doing all of this, what does that mean for my privacy? And the most important thing to know here is that you are in control. Your phone's settings let you do things like turn off location history entirely so your movements aren't saved. You can grant an app location access only when you're actively using it. You really do have the power to manage how and when all this information is used. So there you have it. It's not magic, it's just a really, really clever system. It's this beautiful fusion of satellites in the sky, networks on the ground, and sensors in your hand, all working together to solve the problem of where am I? And that just leaves you with one final thought. Now that our phones have totally mastered this, what's the next everyday, seemingly impossible problem that they're going to solve for us?